Well, greetings everybody. So I want to make a video that is a follow-up to this prompt about whether this indefinite integral was solved correctly or not. And I have here all my steps for solving it and my final answer, which you see here. And I note in this problem that x is a variable, okay? So the fact that that says dx, every indefinite integral has this d and then a letter. That would signify that x, or whatever this letter is a variable. And then it says intentionally here that k is some unknown constant. Okay. So in my other video that I've already made, I said, well, variables and constants are different things. Okay. Variables such as the x here can take on different values, but constants are fixed. They don't change. Okay. Now, I would like to give you some additional context for that. Maybe something specific rather than just x and k and so on like that. So here I just searched on the internet. I said continuous compound interest formula. That's something that you've probably seen before if you're in this class. And look at it right here. It says that a is the final amount, p is the initial amount. Then there's this e right here, which is not indicated by the arrow. Then it says r is a rate of interest and t is time. Now, all of those things, a, p, r, and t, are all variables. They can be different in different situations. The time length of an investment can vary. The interest rate can vary. The initial amount that somebody invests can vary. And the final amount can vary as a result. So those are all variables. They can be different in different situations. But this letter E right here is a mathematical constant. It never changes. It's always the same number. It's 2.7183 roughly. Okay? So variables and constants are different things. In math, they're all letters of the alphabet. They all have that in common. But as far as the function and the role that they play, that's different. Okay, so yes, all of this stuff, the amount, the time, the rate, varies by situation, but that letter E right there is fixed, okay? So that's what I'm leading at here is that, well, okay, in this problem, x is a variable and k is a constant. Now, why would that matter? Well, the rules are different for variables and constants. So in calculus, yes, we treat variables and constants differently. So here, if I have the indefinite integral of x to the n power dx, the fact that says dx signifies that x is a variable. So for any problem that you encounter like this, with a variable raised to the power n, the result is x to the n plus 1 power over n plus 1 plus c, or whatever that variable happens to be. I have an example here that I'll show you in a second, because you might not have an x. The variable could be different. Remember what I just showed you? Time can be a variable. Our interest rate can be a variable. The variable doesn't have to be x. Maybe that's typical, but it doesn't have to be that way. And then I have the second rule. It says the indefinite integral of k dx. All right, so in that scenario, k is a constant and x is a variable. So how you treat that is you'd say, okay, the antiderivative, the indefinite integral of k with respect to x, k dx is kx plus c. Okay. All right. So that's, notice like I didn't say, well, I'm going to raise the power to a 2 there. Right? That's not how it works. That's not what the rule says. If we have a constant like that, that's what we do. The last thing is if I have a constant times some function, whatever it is, some function of x. So here, f of x is some function of x, dx indicates x is the variable, and k is a coefficient, it's a constant. What this rule says is that we can find whatever the indefinite integral of that function f of x is, and just multiply it by this coefficient k. So it's like the k just gets carried into the answer. All right, now let's see an example of all of these. So if I were to look at this one, remember I said that the variable might be x, but it might not. This rule just shows you how you treat variables, what you do with them when you see them, versus constants, okay? So in this problem, I see dr, and that means that r is the variable. Now, I think it would be good to intentionally say that n is a constant, but we could assume that by default because dr means r is the variable. That must mean this other letter is a constant. Okay, we'll only have one variable in these problems, but nonetheless, I'm going to say n, that letter right there, is a constant. R, according to this, is a variable. How would the rules apply? Well, according to this rule, since that indicates a variable, we would say r to the 4th power becomes r to the 5th power over 5. Okay. What about 2n? Well, if n is a constant, if n is some fixed, unchanging number that we don't happen to know, then that's like this. We just say, well, we take that constant, whatever it is, and we attach the variable to it. Okay, so yeah, if n's a constant, well, 2n is a constant. 2 times n is still a fixed number of some kind. So I just attach the r, the variable, to it. So I get from this, r to the 5th power of 5, from this, 2nr, and then I put plus c. Speaking of constants and variables, what's that plus c? Well, I've explained that in other videos I made introducing this subject, but that's called the constant of integration. And the reason we have that is that the way that this works is this is called an indefinite integral, but it's also called an antiderivative. So if I were to take the derivative of this with the appropriate rules, I should get this in here. And that's true whatever this is plus any constant. All right, so that's why we have the plus c. Now, so I want to say that whenever we have problems like this, calculus problems of any kind, don't focus on the letters. Don't focus on whether you see an x or a y or a k or an n. Focus on what's revealed to be constants versus what's revealed to be variables. Okay? All right, so let's do a few more and then we'll go back and we'll talk about that original problem from my prompt. So here, what's the variable? That dk right there means k is the variable. Okay, so k to the 4th power becomes k to the 5th power over 5. All right, what about n? Well, n is indicated to be a constant. All right, so remember that rule I just showed you? If n is a constant, if n is some fixed number, even if I don't know what it is, if I know that it's a fixed number, then n to the 3rd power would also be a constant. It would also be a fixed number. If I take that and put a 3rd power on it, that's not going to make it a variable. So I take it would be n to the 3rd power times k. That's what my rule would give me. And then plus my constant of integration. So that's how this one would work. Okay? All right, now back to my original prompt. I guess what went wrong with it is for me to say that k squared right there in the context of this problem where x is the variable and k is a constant, it wouldn't become k to the 3rd power over 3, because if I was going to take this from here to here and then to here, I would be treating the k like it was a variable when it's a constant. Okay, so this was wrong and this was wrong. Okay, what that should be is this. Should be k squared x. All right, because k is a constant, k squared is therefore also a constant. Our rule gives us the fact that the indefinite integral of a constant squared is that constant, whatever it happens to be, k squared in this case, times x. All right, so my final answer in corrected is going to be x to the 3rd power minus x to the minus 1 power plus k squared x and then plus c. So that's what it should be. So note my corrections there, note what I crossed out, consider my reasons for it, and consider that this is the way that it should have been from the beginning.